Hi everyone. In the continuation of the previous video, that is the N channel enhancement type MOSFET I am discussing. So in the previous part, I discussed the construction part of the nmos. Okay, nmos. So here I will distance all the region. Okay. So I am telling. Okay, this is the output characteristics. This is the output characteristics. Okay, output characteristics. Okay. If you want to write if you want to know the like that the means the transfer characteristics it happen between the output versus input. So this is the id and this is the vgs. Okay, so you know already, if the vgs is less than vth, that is the cutoff region, and the no current will be there. Okay, but if we increase the vgs with vth, then the parabolic amount of the current will flow. After that it will be saturated. So this is called the VTH, that is the threshold voltage. Okay. So I am discussing the sum point. This is the ID versus. So this is the transfer characteristics. Okay, transfer characteristics. The transfer characteristics. Okay. I think I am discussing the some basic point about the NMOS. In case of the NMOS, the drain is higher potential. So this, I mean, the drain is higher potential, and because of that, we apply the positive voltage on the drain, no, as respect to the source. This is the drain terminal, and the source terminal is the lower potential. This is the lower potential. Okay, this thing you should remember, potential. Always, this thing always open, and the current will always ID current will always flow from the drain to source. This current is always flow from the drain to source. ID current. So ID current will always from drain to source. What are the representation of the NMOS is there? This is the symbolic representation of the NMOS is there. This is the one thing. So this is the gate, and the drain terminal is always the higher potential, and this is the source terminal. Okay, and the arrow is always in the source terminal. The direction of current is like that, IDS, the drain to source. Always in case of the NMOS, current will flow. This MOSFET is used in the analog design, but in the digital design, mostly we will use like that. This is the NMOS. No need to write anything. Okay, if we write the simply, so this is the drain terminal, this is the gate terminal, this is the source terminal. This is the representation of the nmos. And other thing is also there, other representation is also there if you want to know, but that is not useful. Okay, for your understanding purpose I am telling. Actually, the channel is not there, the channel is in the bracket called, so if the channel is like that, in that case. Okay, so this thing I am telling. So the drain is higher potential. This is terminal is drain, this is the source, and this is the body. So this is the gate terminal. In that, the body I will also represent. So this is the body terminal. This is the the arrow will represent the n channel or p channel. Actually, this is the p and this is the n. Okay, the direction are always from p to n. So this represent as the n. So this is the n channel enhancement type MOSFET, means the NMOS. This is also this one representation is there. Okay, and also one representation is there. You can sort the, actually if you want to same figure I am writing. Okay, in the same oh, okay, I'm drawing this different figure. Okay, this thing, and this thing and this thing like that. Okay, so every time I told like that, this is the gate and this is the drain terminal, and the short and the body and source always short circuited. So this is the arrow direction, this is the body terminal, this is the source terminal, this is the figure is also nmos. But mostly in the digital design I will use this figure. In analog design, these three kind of the figure will be used, but in digital I will use only these three things. Okay, I think video, yeah, no problem. Okay, so this is the thing, and again I am writing the equation of the current. Okay, so I think you have an idea. If the vgs is less than the vth, this is the cutoff region, no channel is created, the cutoff region, and id current is 0. Okay, but the vgs is greater than vth. If vgs is greater than vth, In that case, there are the two possibilities there. So there are the two possibilities there. One is the linear region. One is the linear region. How? VGS greater than VTH, and simultaneously the VDS less than VGS minus VTH. This is the condition of the linear region. Okay, and if and what are the current expression? You know already. That is the mu1 COX W by L into VGS minus VTH into VDS minus VDS square by 2. Okay, and in case of the, if VGS greater than VTH, then one condition, if VDS greater than, greater than VGS minus VTH, then equal to, you can say here. Okay, if the VDS greater than VGS, this is the case of the saturation region. In the saturation region, MOSFET behaves as amplified. Okay, so this is the saturation region, and in that the expression of the current is the mu1 CX, yeah, Kn by 2, you can tell Kn by 2, and VGS minus VTH whole square. Okay, this is the thing. And Kn is equal to, this is Kn is a process parameter, a transconductance parameter. The value is mu1 COX W beta L. I think you understand the basic thing. Means what the thing is needed, no? That thing I am telling here. Okay, not I am discussing totally about the MOSFET DC analysis. Okay, that thing, if I discuss the resistance, transconductance, this is the different thing in the analog part. So here I discuss the all the basic thing, the cost, what are needed for the construction of MOSFET. Okay, and again I am telling one thing is also there. So the PMOS I am telling orally. So the everything analysis, every thing is the same. If we discuss about the the P channel enhancement type MOSFET, that is the PMOS, everything will be same. And one thing also I need to write in case of the actually the nmos. In case of the nmos, the vth, the threshold voltage will be positive, because the positive voltage we are applying on the gate na. So the vth will be positive, and vds will be positive. Vds always it will be positive, and the vgs is also positive. These three things you need to remember. VTH, VDS and VGS, all things will be positive. Okay. Just I am giving the some idea about the PMOS also. The PMOS. I think you can easily draw. The P-tap and the analysis you can easily do. Otherwise, the video will be very lengthy. You can explain easily, no problem. In case of the PMOS, the representation of, in case of the PMOS, the source terminal is higher potential. Okay, source, and this is the drain. The source terminal is higher potential. This is the higher potential. If you want to complete analysis of the PMOS also, then you can comment on. I will explain in the another video. Okay, source and drain is the lower potential. So this is the difference between the nmos and pmos. In case of the nmos, drain is higher potential, source is lower potential. But pmos, source is higher potential, and the drain is lower potential. This is the difference. Okay, and the figure representation, there the two representation is like that. Arrow will be always in the source terminal. Okay, so this is the gate, this is the source is higher potential, and this is the drain terminal. Okay, this is the figure of the analog design. But in the digital design I will use this figure only, this figure only. Okay, this figure, just I will invert here. This figure, this is the source terminal, this is the drain terminal, and this is the gate terminal. Actually this is the inverted, means I am telling like that. This is the inverted, this inverter symbol, and like that. This is the PMOS symbol. This symbol I will use. Okay. So but in case of the PMOS, so the source is higher potential, drain is the lower potential. Okay. Here in case of the PMOS, the threshold voltage VTP, actually to invert the channel we need to apply the negative voltage on the gate terminal. Okay, and VGS will be also the negative. That thing you should remember. the VTP so will be negative. Actually we need to apply the negative voltage on the gate terminal. Because of that I want to firstly I need to create channel na. So the VGS will be negative, okay, and VTP will be also negative, and the VDS will be also negative. Okay, this is the thing. And if you want to write the expression, this thing will be different. This thing I think okay, no problem. So the VTP, VGS and VDS all thing will be negative. Okay, but if we write the in the reverse way, another form is also there to write the expression. If we interchange the terminal VSD and actually source is higher potential VSD and VSD, if I write, then it will be positive. This way you can also write, no problem. This way we can also write, no problem. Okay, again I am telling. Then here actually in nmos I use the vgs, na, that's why I am using the vgs here. If the vgs is less than vtp, one thing I am telling in the analysis of the pmos, always we will sign. Actually vtp will be negative, no, so no need to take mode. Okay, another method is also there. I am telling in the I am telling the easy method. Actually vgs will be negative, vtp will be negative. If this thing is happen, then the pmos will be on. Okay, then pmos will be on. If the vgs, the express the inequality chain will be sent. If the vgs will be greater than, I am not taking the mode, you should understand that thing. If the vgs is greater than vtp, then it will be off. Okay, you can also write the this way equation. If anyone told like that, sir, it is not you are not telling right. vgs is less than vtp, I told. In that day, in this case I will take sign as it. Otherwise we can also write like that. If we write vsg will be positive, and the vtp mode. So this way you can also write like that, no problem. This way you can also write this thing. But mostly to analysis of the inverter I will use this thing. Okay, no problem. This way you can, yeah, vst greater than vtp ka mode, otherwise vgs less than vtp. Here I will not use any mode. The same, what are the negative value I will use. Okay, no, I think you understand. I hope you understand. Okay, if the vgs is less than vtp, sorry, greater than vtp, it will be off. Okay, this way we can yeah, here you can also write like that in the form of the mode, this expression. If the vsg vsg, okay, if the vsg is less than vtp ka mode, VTP mode, then it will be off. Okay, so these two thing is there. You can follow also, but I will always follow the first issue. I will always follow this is. If the VGS is just, if you need to change the inequality. If the VGS is less than the VTP, then it will be on. If there is a on condition is there, there are the two possibilities there. One is the linear region and another is the source region. If the MOSFET will go into the linear region, the current is and other. If VGS less than VTP, and also will change here, the condition will be changed. VDS will be greater than equal to VGS minus VTP. Always I am telling you, you need to use the negative value of the VTP, not the positive value. Okay, negative value of the VTP. I am not using the mode. Just inequality sign will be changed. Here, if the greater than symbol in the nmos, then it will be saturation in nmos. But here greater than means the linear region. The linear region current expression will be same. The Kn mu p cux w by L Kn into VGS minus VTP, okay, into VDS minus VDS square by 2. I hope you understand. Okay, and in the saturation just inequality you need to change the sign. Here the VDS less than VGS minus VTP. Always you will use the sign, not mode value. Negative sign here the VTP will use. VDS less than VGS minus VTP. Then the current equation is here. Sorry, here we need to write the KP. Actually, this is the pmos, no, KP. KP by 2 VGS minus VTP the whole square. This is the expression of the current. That is the Kp is equal to here mu p cox W bata L. I hope you understand. Okay. So here I complete analysis the N channel and the depletion N channel enhancement and the P channel enhancement type MOSFET I discussed, and the current also I discussed. I think you don't have any doubt. If you have any doubt, you can ask in the comment section. No problem. I will give the answer. Okay. P type analysis you can do itself. So if you tell this way to the interviewer, definitely he will be very happy if you explain the construction of MOSFET this way. Okay. I think basic thing I explain. Okay, in the next part we will meet what I will discuss. Okay, so thank you guys.